A very good morning to everybody. Today I'm going to explain about the lab 27.2.15, which is investigating a malware exploit. So in this lab, you are going to use the Kibana to learn about a malware exploit, investigate the exploit with Seagull, use the Wireshark to investigate an attack, examine the exploit artifacts. So this lab is based on exercise from the website malwaretrafficanalysis.net, which is an excellent resource for learning how to analyze the network and also the host attacks. I learned a lot from this website. So thanks to Brett Elias, malwaretrafficanalysis.net, for permission to use the material from his site. Okay, so let's jump into the background or the scenario. Now, you have been decided to interview for a job in a medium-sized company as a Tier 1 cybersecurity analyst. Okay, so you have been asked to demonstrate your ability to pinpoint the details of an attack in which a company was compromised. So your goal is to answer a series of questions using Seagull, Kibana, and also the Wireshark in the security onion. Now you have been given the details about the event. So the event happened in January 2017. Wow, that's a long time ago. And it was discovered by the Snort NIDS. Okay, so these will be the two resources that is needed. You need to have a virtual machine, which is a security onion, and also the internet access. I already installed the security onion. You can able to see it in my desktop here. Okay, so we will jump to the part 1. So the part 1, the question is asking us to use the Kibana to learn about the malware exploit. So in part 1, you're going to answer the following questions. To help you get started, you are informed that the attack will took place at sometimes during January 2017. So you will need to pinpoint the exact time. Okay, so narrow down the time frame. So you have to log in to the security onion with the analyst as your username and the password as a CyberOps password. So from here, you open up your security onion virtual machine and your username is analyst. Password will be CyberOps. Okay, then you just press login. Then while waiting for the virtual machine to boot up, so you will see here there will be a Kibana. So you double click on the Kibana. And again, you are required to enter the same user ID, okay, the user, and also the password will be CyberOps. Okay, so it will loading the Kibana. And you will see that the dashboard right now in the left-hand side, okay, in the left-hand side, there will be the dashboard, and also at the top right-hand side here, you will see the last 24 hours. Okay, this one. Look at my cursor and you click on that last 24 hours at the top right hand side and you look for the menu which is called absolute. Okay, and the question just now is hints you for the January 2017. So what you need to do is you have to click on the month and also the year here to adjust the year first, 2017, and make it as January 1st until 2017 and make it as January 31st. Okay, then you hit the button go. Okay, so when you hit the button go, you will see that there will be a tiny dot in here. You just click and drag. You click and drag, touching the tiny dots there, so that you get a graph. Okay, so you repeat the same steps again until you get something like this. Okay, and you can repeat again. So you already done number C. Okay, you will see the graph appear with a single entry showing that. So to view more details, you need to narrow down the amount of time, which is the one that I already did it. Okay, I already narrowed down. And how do you narrow down? You just clicking and dragging, okay, to select an area around the graph data point. Okay, that's the one that I showed you just now. Okay, so basically you already done this graph. So let's go to the step 2. Now for this step 2, you're going to locate the event in Kibana. So after narrowing the time range in the main Kibana dashboard, go to the NIDS alert data dashboard by clicking NIDS. So you go here, alert data, then you will see that there will be the NIDS. Just click on the NIDS, all right? And then from here, you go to B. So the B is asking you to zoom in on the event, clicking and dragging in the NIDS again. So you can repeat the step just now. Can just zoom in, click and drag. And after that, the visualization further focus on the event timeline. Yeah? So since the event happened over a very short period of time, so you have to select just a graph plot line. So you have to zoom in until your display resemble the one below. Okay, so it's exactly the result that I'm getting. All right. And then click the first point on the timeline to filter for only that first event. So this will be your first point. You just click here. Okay, so now we are going to view the details for events that occur at that time. You scroll all the way at the bottom of the dashboard until you see the NIDS alert section, okay, of the page. The alerts are arranged by time. So you expand the first event in the list by clicking the pointer arrow that is on the left of your time span. Okay, so we scroll down until the bottom here, and you will see that is the NIDS alerts. Okay, and from the time here, you can just pick up the first one. There's an arrow. You can just click on this tiny arrow, and they will view all this information for you. Okay, so we have done. So we already expanded all the details, and we're going to answer the questions. Okay, so the first question: what is the time of the first detected NIDS alert in Kibana? Can you find the answers? Okay, it's here. The timestamps will be on January 27, 2017, and then your time will be 22:54:43. So this is the answers. Okay. And next, what is the source IP address in the alert? So you can find the answers for the source IP address, which is you can scroll down a little bit and you can see this is the source IP address 172.16.4.193. Okay. And the next questions, what is the destination IP address in the alert? Okay, so we go and find the destination IP, which is you can find it here, the one that I highlighted, 194.87.234.129. So this will be a destination IP. And then what is the destination port in the alert? And what service is this? So you can scroll down, okay, and you can look for your destination port, which is the one that is here. And it's 80. I believe that everybody know that this 80 is a service of HTTP, right? Okay, so that will be your answers. And next, what is the classification of the alert? So if you look at here, the classification, go and search for the classification of your alert. Okay, see whether you can find it or not. This is the one, classification is Trojan activity. Okay, Trojan activity means when you do some action, then only you will activate that Trojan. Okay, so that is the answers. And then what is the destination geo country name? So you look for your destination geo country name will be Russia. Okay. All right. So we have done. So we go for the F. Now in a web browser on a computer that can connect to the internet, you go to the link that is provided in the signature info field of the alert. Signature info. So go and look for the signature info. Okay, signature info, which is here. This is a signature info. And this will take you to the emerging threats snot alert rule for the exploit. Now there are a series of rules shown. So let me just go and click on this, then you will see it will show you these emerging threats. Okay. This is because the signature can change over the time, or new and more accurate rules are developed. So the newest rules is at the top of the page. You're going to examine the details of the rule. Now, the first question is asking you, what is the malware family for this event? So you go and search. Can you see any malware family? Okay, in this patch here. So I can see the malware family will be exploit kit RIG. Okay, so that will be your answers. And next questions, what is the severity of the exploit? So if you can see here, the severity is major. Okay, and next, what is an exploit kit? So you can search on the internet to answer these questions. What is an exploit kit? So you go to your virtual machine Kibana here and you click on the new tab and you just type what is an exploit kit. Okay, you press enter. Then it will link you to this website and you can have a look. You can read for this explanation. So the exploit kits are automated threats that use compromised sites to divert a web traffic, and then it will scan the vulnerable browser-based application and also run a malware. Okay, so this exploit kit will develop as a way to automatically and silently exploit the vulnerabilities on the victim's machine while browsing the web. So we were going to investigate this after this. Okay, so this will be our whole lab exercises for today. Yeah, we're going to observe about these exploit kits. And the rest of this explanation, you can refer to other of the Google, okay, explanation about the exploit kit. So this is just an example. Okay, so we move on to the step 3. You view the transcript cat me. So what you need to do is, okay, you go back to the Kibana. You click the alert ID value. Okay, you can pivot to CatMe to inspect the transcript of the event. So you can just go to the ID. Okay, go and find the ID, okay, which is here. And you can just click on this link and you are entering to the CatMe. Okay, so this is all the information that you can get. Exactly as what the slides is trying to tell you. Okay, let me just enlarge this so that you can see more details, yeah? Okay, so when you scroll down here, you will see that the blue text is actually the PCAP files related to this alert. Okay, the IP addresses will be 172.16.4.193. Then this is your port number, and then all these file will be PCIP files. Okay, then when you scroll down again, you will see that the CatMe detected GZIP encoding. Now, GZIP encoding means that the requested file was being compressed. Okay, it's a GZIP compressed files. And you also find out that the timestamp is the one that we observed just now, is for on 27th of January 2017, and the time is 22:54:43. So that would be the timestamps, exactly as what we observed, right? Okay, then you will have the GET request for the files and also the compromise referring website. Okay, so it refers to www.homeimprovement.com. Okay, and then you remodeling your kitchen cabinets.html. Okay, so that is the referral. So the compromise referring website. That means the user is trying to type the keywords for remodeling your kitchen cabinet for this page. And then it will be referred to this home page called homeimprovement.com. Okay, so that's how it means. Now, you're going to what website did the user intend to connect to? Okay, so I already showed you just now. This user is trying to connect to the website called www.homeimprovement.com. Okay, so what URL did the browser refer the user to? So once you have typed this user is logged into this website, so it will have the referral. Okay, it will goes to the referral. So let's look at our result here. You can go back to our results, and you can scroll down, and you can see that this is your source host. It will direct you to tyu.bandme.com. Okay, so that is how the URL refers to the user, okay, to this page. Okay, so what kind of content is requested by the source host from the TYBEN? Okay, we call it tybandme.com. What could this be a problem? So you look in the DST server block of the transcript too. So you can see here, you will see that all the information for this source accept encoding will be in the gzip deflect, okay, in the compressed files. The content is shown as a gzip, is a compressed folder. So this could be a malware file that has been requested for download. It's probably malware files because it is a compressed files. Okay, the content of the file are obfuscated. It is not easy to see what is in the file. Okay, then you close the CatMe browser tab. You just need to close the CatMe browser tab, and you go back to Kibana. So from the top of the NIDS alert dashboard, you click the HTTP entry located under the Z hunting heading. So you go to Zen hunting. Okay, on the top of this Z hunting, so you will see this HTTP. So you click on the HTTP, and then verify that your absolute time range will be still 27th of January, but now you focus on the time stamp, which is 22:54:30. Okay, this is from this timestamp. So we're going to repeat the same step. So what you need to do is you can just go to the top right here. Okay, there's a date. And then click on the date, and there's a from. Okay, you choose the January 2017. Now it's already correct. And then the timestamp will be 22:54:30. So this 42, you change it to 30. Okay, then after that, this one also the same, January 27. So you have 56. Okay, this one will be 56. And this 43, you change it to 00 as what the question want. Okay, then after that, you hit the go button first. Okay, and you scroll down to the HTTP site section of the dashboard. So you scroll down to the HTTP site session, and this is your site, www.homeimprovement.com. You have tyubandme.com. You got www.bing.com, and so on. So all these answers will be at your site. Okay, so you can list down. Now, after you have list down, we should know that this website from the transcript that we read earlier, not all the sites that are known are part of the exploit campaign. So you're going to research the URL by searching for them on the internet. So do not need to connect to them, yeah? Okay, so you have to place the URL in quotes, means a double quotation, when you do the searches. So how am I going to do this? Let's say I'm trying to use the tyu.bandme.com. So I'm going to copy this Ctrl+C, and I open up the new page. Then it will direct me to the Google. And I type this and I put double quote. Okay, so once I have done this, I just press enter. And you will see here, I already placed this one, and then you can see the free automated malware analysis service. This is the one, any run, okay, HTTP tyu.bandme.com, and then you will have another one which is here, urlscan.io. Maybe you can try another one, which is this P27. This one you can Ctrl+C, and then you go back to the tab that you opened with the double quotation just now and replace it. Okay, then you just press enter. Wow, so when you have this, when you press enter, they will have a lot of results related to this. So you will know that there will be the possibility that this is the exploit campaign. Okay, so that's about this explanation here. You can try it one by one based on your Kibana result, yeah? Okay, so what are the HTTP MIME types listed in the tab cloud? So you can just go down here in the tab cloud. Okay, this one, HTTP MIME type tab cloud. So you will have tags/HTML. You got the tag/plan, and then you have the image/GIF, application/JavaScript, application/X, shortwave, flash, and so on. So that will be your answers. Okay, so we have done the part 1. So now we will going to do the part 2. So for the part 2, you're going to investigate the exploit with Seagull. So in the part 2, you will use the Seagull to check the IDS alert and gather more information about the series of events related to this attack. So the alert IDs used in this lab are for examples only. The alert IDs on your VM may be different. Okay, so first you're going to open the Seagull and locate the alerts. So now you're going to close this Kibana. Let's close the Kibana and you go to open up your Seagull and you launch the Seagull from the desktop. Again, your username will be analyst, your password will be CyberOps. Okay, so once you have done this, you enable all the sensors and click start. You can just enlarge it and then you can just press the button of select all. You enable all these sensors and then you just start your Seagull. Okay, so once you have done this, you locate the group of alerts from January 27, 2017. Okay, so according to the Seagull, what you need to do is you have to locate the January 27. January 27, which is here. Okay, this will be a January 27 until this January 27, because after this will be on June 27. Okay, so this will be your beginning, starting, and this is ending. Okay, so the entire exploit occurs is less than a minute only. So you can see here the beginning is 22:54:42, and then here the last one is 22:55:28. So it just happened not more than 1 minute. Okay, so that's how the Seagull will help you to observe, okay, for this event. And next, we go for step 2. Investigate the alerts in Seagull. So click the show packet data and show rule. So we're going to show packet data and show rule. We click these two buttons. Look at my cursor. Okay. And then we look at the questions here. The question is asking us to select the alert ID 5.2. So the alert ID will be in this tab here. Okay, then you choose 5.2, which is the one that I'm clicking right now, highlighted in the yellow color. So this will be my alert ID 5.2. So according to the IDS signature, which malware family triggered this alert? You may need to scroll through the alert signature to find this entry. So let me check what is the malware family for this, yeah? The question is asking you to check the malware family. So if you look at this preview here, it seems like you can just enlarge it a little bit. And then you can go to this tab at your right hand side and you just drag and drop. Okay, so that you can see this one in more details. So you scroll down, okay, and try to see is there any malware family. Okay, this is the one, malware family. So you have the pseudo dark leech. Okay, so this will be your malware family. Now, we're going to maximize the Seagull window and the size of the event message column so that you can see the text of the entire message. Yeah. Okay, so how you do that? You will have this column. You can just adjust it so that you can see more on the event message. So let me just adjust these parts. Okay, if not enough, you can just adjust again. Yep. All right. So after that, you will see the whole event message will be here. Yeah. So look at the event message for each of the alert ID related to this attack. Now, according to the event message in Seagull, what exploit kit is involved in this attack? So what will be the exploit kit is involved? So you click on the date or the time. So you can see here, this is the January 27, January 27, January 27, January 27. All this is January 27, right? So the exploit kit will be the one that with the RIGEK. Okay, can you see this? RIGEK, RIGEK. So all these, okay, are the exploit, the EK exploit. Why I said so? If you look at the destination part, it will be HTTP. At T, then you use using the RIGEK. This is using the HTTP also, which is RIGEK, and this one also RIGEK. All these three is for on January 27. So beyond the labeling the attack as a Trojan activities, what other information is provided regarding the type and the name of the malware involved? So you can see here what other type, yeah? You can see here, this is on the 27th of January as well. So you will have Trojan ransomware, which is a server, okay, server check-in. So this is the malware ransomware server. Now, by your best estimate looking at the alert so far, what is the basic vectors of this attack? How does this attack take place? Okay, so you can see here, basically, all this attack seems to be placed at the visiting of the malicious web page. Okay, so you is actually visit a certain page and then it will refer to the certain website. Okay, so this is what you observe. Okay, next, we will go for step 3. View the transcript of events. So now what you need to do is you go to the alert ID 5.2, which is this one, alert ID 5.2, and then you right click and you select a transcript. Okay, so you have this info. And just for your information, this info, if you get the blue color, it will be the request. And if you get the red color, it will be a reply. Okay, all this is reply. And blue color is a request, and this is reply. The red color is reply. So what the question wants you to do. So when you continue to hear what are the referral and the host website that are involved in the first SRC event. Okay, so if you look at this result here, the user is actually goes to search for the home improvement remodeling your kitchen. Okay, then it will be directed to the page of www. That means he or she went to www.bing.com, then search for the keywords of home improvement remodeling your kitchen. Okay, so that will be our finding. Okay, it's exactly the one that I mentioned just now. The user issue a search on the Bing with the search terms home improvement remodeling your kitchen. So the user click the www.homeimprovement.com and it will link, okay, and visited that site. Next, we right click the alert or ID of 5.24. So we can close this. Then you can go to alert ID 5.24. Then you right click. Then you view the transcript again. Okay, so what we want to do, say what kind of the request was involved. So if you see here, the request is get, okay, all these info, and then you will have engine classes, JS, okay, DLE, JS, and then you have a HTTP /1.1. Okay, so this is the get request. So where are the files requested? So you can see the files here requested at the DLE. underscore js dot js. Okay, so that will be your answers. And what is the URL for the referral and the host website? So if you can see here, the referral, where is our referral? Okay, this is your referral, www.improvement.com. Okay, remodeling your kitchen. Again, this user go and search for a keywords remodeling your kitchen cabinets and being directed to this page, www.homeimprovement.com. So that is our finding. And the host website was be retrotips visionbura.com.ve. So it will be directed again to another website here. Okay, source host website, which is retrotic.visionnurbana.com.ve. Okay, so that will be our finding for this. Now, how the content encoded? Okay, so we will know that the content is being encoded using gzip. Okay. Close the current transcript window. In the Seagull window, right-click on the alert. So now we will go for 5.25. So we're going to close this and you look for 5.25 alert ID. Right-click, go to your transcript, and you repeat the steps again. And let's see what the question wants. How many requests and responses will involve in this alert? So as I mentioned just now, the request and response, if you have the blue colors, you will get one request. So this is request. This is the response. Okay, you scroll down. Then this is the second request. Okay, then all this red color will be the second response. Okay, wow, that's a lot. Then you scroll until the end. See whether you got any third request or not. Okay, I got this. So I have a request and I will have the response. So once I click on it, okay, finish already. So what will be the total of the request and the response? So you can see here, I'm getting 3 requests and 3 responses, right? We have the 3 blue colors just now. We have the 3 red colors. Okay, what was the first request? So you move up, cursor, scroll up again. So you will see the first request, which is here, source get, and you get all this info. Okay, application.shtml and so on. Okay, and what was the referral? So this is your referral. It will direct you to homeimprovement.com. Okay, it will direct you to the homeimprovement.com, remodeling your kitchen cabinet. So the whole thing is a referral. Okay. Who was the host server request to? So this host server is actually request to your source host. Yeah, it will request to this website, tyu.bandme.com. Okay. Was the response encoded? Yes, the response is actually the encoded because this response is encoded in the gzip files. So next, we will go for second request. Okay, what was the second request? So you can scroll down here. Your second request is actually getting all this info. Okay, then you can just copy down the whole thing here. And then who was the host server request to? So the host server here, you can see the source host request to tyu.bandme.com. Okay, so this will be your answers. Was the response being recorded? Yes, it's actually being recorded except here encoding and it's a compressed file. Okay, gzip. So, okay, let's look at the third request again. So you scroll down. Wow, you scroll down, then you will see the third request. Every request is actually being recorded in the compressed files. Okay, then here, the third questions. Okay, what is the third request? Yeah? So this third request, again, you are asking to get all this information. Okay, so this will be answers. Then who was the referral? So your referral will be http tyu.bandme.com okay, with all these details. So that would be your referral. Okay, next, what was the content type of the third response? Response means you have to look for the red color. So these are all the information for your reply. Okay, so the content type will be application / AIDS, shortwave flash. Okay, so what were the first three characters of the data in the response? The data starts after the last DST. Okay, so if you see here, this is the last DST, right? So it will start at CWS. So this will be the answer. Okay, the three characters of the data in the response. So what type of the file was downloaded? After you click Control F, then you will see that the file downloaded will be the SWF, which is in the Adobe Flash. So we will close the transcript window. Then you right click the same ID again and choose the network miner. So just now our network ID will be a 5.25. Then from this network miner here, you will see there's a host tab. There will be a files tab, and this file tab will have three info. You will get the HTML, which is a index.html. This one also index.html, and then you will have another files with SWF. So you have two HTML files and one is SWF. Okay, so I already completed the part 2. So now let's jump into part 3. Okay, we have done the part 1 and part 2. So let's continue the part 3. Use the Wireshark to investigate an attack. So in the part 3, you will pivot to the Wireshark to closely examine the details of the attack. Yeah. So how to do that? In the Seagull, you have to right click the alert ID 5.2, okay, with this file's name, and also pivot to the select the Wireshark from the menu. Okay, so you go and search for 5.2. Okay, this is the one that I highlighted here in the yellow color, 5.2, and you right click and go to the Wireshark. Okay, so the default Wireshark setting uses a relative time per packet, which is not very helpful for isolating the exact time and the event occur. So to fix this, we will going to have a view time display format, that times of the day, and also repeat a second times for the view time display format and so on. So I'm going to show you how to do that. And I actually done it already. So how do you do this is go to the view menu. Then you go to the time display format because we want to specifically identify the date and the time of the day. So this one, make sure you select it. And the second one you have to select, which is the second. Okay, then scroll down. We go for a step 2. Now you're going to investigate the HTTP traffic. In the Wireshark, you use the HTTP request display the filter to filter for a web request only. Yeah. So we were going to type http request. The reason is because we just want to view, okay, the filter the web request only. So if you look at here, you select the first packet, and from the packet details here, you expand the HTTP. Okay, you expand the HTTP, and then you answer these questions. Now, what website directed the user to www.homeimprovement.com website? So of course, you have to refer back to the referral. So in this case here, it means that this user is actually trying to go to the bing.com and type the search for the keywords of home improvement remodeling kitchen. Okay, but this website is actually refer to another website called www.homeimprovement.com. But in fact, the user is not browsing to this website. Okay, so let's continue the step 3. View the HTTP objects. Now in the Wireshark, you go to the file, you go to export object, and then you go to HTTP. Now in the export HTTP object list window, select the remodeling your kitchen cabinets.html packet and save it to your home folder. So how are you going to do that? You just click on this remodeling your kitchen.html files are the first one, and then you just press the button at your save here. Okay, so it will redirect you to the home page. So because I already saved it, so in this case, I'll just cancel. Close the Wireshark. After you close the Wireshark in the Seagull, you right-click on the alert ID 5.24 source IP addresses, which is 139.59.160.143. And you have all these details information, yeah? So this is actually at the 5.24 ID. Okay, alert ID 5.24. So what you need to do is you have to right click and then you go to Wireshark. Okay, try to observe these packets. So what you need to do is type http.request because we just want to know the HTTP request for this page. Yeah? Okay, so what is the HTTP request for? So it's very obvious that this HTTP request for this event is requesting to get the JavaScript files, which is the DLE_JS.js. Okay. So what is the host server? So if you expand your answer at the HTTP here, click, and then you will see your host server. Your host is retrotic.visualnubana.com.ve. In the Wireshark, you go to the file, you go to export object, and then after that, you go to the HTTP, and you save these files. So you repeat the same steps, you save it into your home folder. Okay, after that, you close the Wireshark. So then you close the Wireshark, then you go back to the Seagull, and these times you're going to observe this ID, alert ID for 5.25, yeah? Okay, so we go for 5.25, we repeat the same steps, go to the right-hand side, and click on the Wireshark back. Okay, so from this event, what can you notice? So you can see here, you can just go to http.request again. We want to see what happened to this event ID. Then you will notice that it will have the HTTP GET, you will have the post, you will have the GET. So if you observe this, okay, you will notice that these three GET, post, and GET requests that we have looked for is exactly as what we observed earlier on. We have a 3 requests, we got the 3 reply. Remember? Okay. So with the first packet selected, in the packet details area, expand the hypertext transfer protocol application layer data. So you right-click the host information and choose apply as column to add the host information to the packet list column as shown in the figure. So what does this mean? Now, if you look at the column here, we have the number, we have the time, we got the source, we got the destination, we got the protocol, and we got the info. So now I will going to right click and would like to add in the host inside there. So how are you going to do that? You expand your HTTP protocols, then you go to this host here, click on the host, you right click, then you can actually apply as column. So when you apply as column, it will insert the column into the Wireshark here. Okay. So we have done this. Then to make a room for the host column, you right click the LAN column header and uncheck it. Actually, by default, this LAN column is in your Wireshark, but I already removed it. Okay, so I'm going to show you how to remove it. So you can just right click and then there will be the LAN. You can just tick, then it will appear at your menu here. And then you can right click again, then you untick. Then at least you can actually organize your column, yeah? So what you need to do, you just adjust this column so that you can see all the information preview for your source, destination, protocol, host, and also the info. The names of the server are now clearly visible to the host column of the packet list. Okay, so we go for step 4. So for this step 4, you're going to create a hash for an exported malware file. Now we know that the user intended to access www.homeimprovement.com, but the site referred the user to other site. So eventually the files were downloaded to the host from a malware site. Now in this part of the lab, we will access the files that were downloaded, and we're going to submit the hash to the virus total to verify that the malicious file was downloaded. So how to do that? Okay, you go to the Wireshark, then you go to the file, export object, then you go to HTTP. So when you do this, you're going to save the two text/HTML files and the application/x shortwave flash file to your home directory. So you're going to save all this into your home directory. Okay, just press the save button, and when you already save, it should be inside this home directory. Yeah. Okay. So now that you have saved the 3 files to your home folder, test to see if one of the files matches a known hash value for a malware at the virustotal.com. So what you need to do is you have to go to your terminal. So how to go to your terminal? You can just minimize this. Okay. And you go to your home, right click, and open in terminal. Okay. So now you're going to issue a ls-l command to look at the file saved in your file name begin with this percentage 3fbiw is equal to cmonkey. Okay, so you use the ls-l command with the grep to filter out the file name with the pattern cmonkey. So how to do this? We're going to type this command. Okay, so you just follow ls-l pipe grep -i cmonkey. Okay, so when you have done this, you will get exactly the same as what I have here. And you're going to generate a SHA-1 hash for a cmonkey flash file with the command SHA-1 sum, then followed by the file name. Yeah. So you're going to type the first 4 letters, which is this percentage 3FB, okay, of your file name, and then you have to press the tab key to auto-fill the rest of the file name. And then you press the enter, and SHA-1 sum will compute a 40-digit long fixed length hash value for you. Okay, so how to do that? You can just go to the SHA-1, go back to your terminal, and type SHA-1 sum, and enter the letters of percentage 3FB, then press the tab key. You press enter, it will give you this code. Okay, so what you need to do is you can copy this code. You go to applications, go to your accessory, and open up the gedit here and paste your code inside here, because later we're going to do the comparison. Yeah. Okay, so I already copy these numbers, the hash numbers. Okay, so what you need to do next is we go for a D. You can also generate a hash value by using the network miner. So you need to navigate to Seagull and right-click the alert ID of 5.25. So this is the details of the event. And then you can select the network miner to pivot to the network miner. So select the Files tab. So in this example, you right-click the file with the SWF extension and select Calculate MD5, SHA-1, SHA-256, and hash. So how are you going to do that? Now we navigate to the Seagull. Then you choose the event ID of 5.25 that I highlighted in the yellow color here. Right click, and then you click on the network miner. Okay, choose the network miner. So you can click on the files, the second tab, yeah, for the second tab of the file. And you can actually right click, go and find the SWF, this the third line, .swf, then you right click, and then you calculate, you click on this calculate. Now, once you calculate, then you copy this info, SHA-1. Okay, this is the information start from 97. Okay, so you just right click copy and then you pass it to here. The SHA hash value is the same. Okay, so you open a web browser and go to the virustotal.com. So you click the search tab and enter the hash value to search for a match in the database of the known malware hatches. Then you go to your this what you call that, the web page, and then you type virustotal.com. Okay, type on the virustotal.com. Yeah, you will be directed to this page, and there will be a search button for you. This one, search button. Click on the search button, and we're going to paste our code inside here. So copy this code first. Control C and paste it here. Okay, then you search. Now, VirusTotal will return a list of the virus detection engine that have rules to match this hash. You're going to investigate the detections and the details tab. You review the information that is provided on the hash value. So what did the virus tell you about this file? So you can see here the information will be different, might be vary, okay, from the answers that I have. So you can see now it's already been updated. 32 engines detected this file over 55. Okay, so you will know that these detections is actually reported in the VirusTotal. Okay, then you close the browser and the Wireshark. Okay, you close this browser and also the Wireshark. Then you go back to the Seagull. Okay, and now you observe for the event ID of 5.37. Okay, we're going to observe this event ID 5.37. So choose for 5.37. Okay, this is the one highlighted in the yellow color, and you're going to examine the HTTP request. So go to the right click, go to the Wireshark. Okay, so you're going to request for http.request. You're going to observe what is happening here. Now, when you do this, are there any similarity to the earlier alerts? Yes, I can find. You have a look of the info here. You can see there will be a get, there will be a get, there will be a post. Okay, and then the full request, the URI is requesting to tyu.banme.com. Okay, so it's quite similar to what we observed earlier on. Okay, next question. Are the files similar? Do you see any differences? So you can go to the file, you can go to export object, HTTP, then you will see that, yeah, the file is similar, which is the hostname which directed you to the tyu.banme.com. So you got two tags, and you also got one shortwave flash. Okay, so the file types is very similar. Okay, just that the file name is different only. You can see a very weird character for the file name. Yeah. Okay, so now you create a SHA-1 hash of the SW file as you did previously. Now, it's the same malware that was downloaded in the previous HTTP session. Just now, the event is 5.37, right? So you go to the network miner. So when you go to the network miner, you can just go to the files and choose for SWF. Right click, calculate the MD5 SHA-1 hash value. So this is the hash, and you can just copy this value. Copy. Okay, so we already create the SHA-1 files, okay, for our SWF files that we did earlier on. Yeah. So is this the same malware that was downloaded in the previous HTTP session? Okay, let's try to compare. So this is my file just now. I will just press enter. Okay, when you pass, yes, it is the same. If you refer this to the files here, is the same 97A80, 97A80333, and so on. So it's the same number. Okay. So that's why your answer is yes, the two hashes match even though the file names are different. Okay, so we continue in the Seagull. The last four alerts in this series are related, and there also seems to be post-infection. Now, why do there seem to be post-infection? If you look at here, the last four, yeah, okay, so this is our January 27th of January, the first event. Then our last event is this. Again, January 27th, this is the last. This is the second last. This is the third last. This is the fourth last. Now, if we look at the event message here, yes, it is actually directed to the Trojan ransomware, which is the server. Okay, it is a post-infection because it's communicate to the malware server. Now, what is interesting about the first alert in the last four alerts? So you have to choose the last four alerts. So from this fourth last here, we right click and then we use a Wireshark. Okay, you go to the Wireshark, then you will see here there's a time, there is a source, there's a destination, and there is the protocol that is referring to the UDP. It sends a UDP code to a ransomware checking the server. Now, what type of communication is taking place in the second and the third alert in the series, and what made it suspicious? Now, if you look at the second destination pop is 53, which is the DNS, and the event message is go to the Trojan ransomware. That means there will be something to do with the request of the malware server. Yeah. So we go for the last alert. If you see here, the one that I highlighted, I'm going to pick up 5.78 ID because this is the last alert. So I go to File, I go to Wireshark. Okay, 5.78. And I go to the file, export object, HTTP. Okay, so this one is worth for saving. I just save it into my home folder. So you can just save it. So what is the file name? The file name is the one that you can refer here. EE7E is a very huge name. Okay, finally we have done the part 1, 2, and 3. So now let's move on to the part 4. And the part 4, we're going to examine the exploit artifacts. Now in this part, you will examine some of the documents that you have exported from the Wireshark. So in the security onion, so this is my security onion. You open the remodeling your kitchen cabinet HTML files using your choice of text editor. Now this web page initiated the attack. So normally we save it at the home page just now, right? So you go and open. Okay, and you choose the remodeling your kitchen cabinet.html. You right click and you open with gedit files. Okay, so this is the one. And the next question is asking you, can you find the two places in the web page that are part of the drive-by attack that started the exploit? Okay, we're going to investigate this after this, but the hints given here will be the first in the head area, and the second hints will be in the body area. Okay, so the script tag here, you can see from the head profile, there'll be a meta title link to where. Okay, so the one that suspicious is this script. Okay, because this script is calling from the source retrotip.visualnubana.com and requesting for the file which is DLE_JS file. So we already found this in our head. Then we try to go for the body. So we can just go to search body. And you can find that in the body class here, there will be the iframe. And the source is for HTTP tyu.bandme.com. Okay, this one seems to be very suspicious that they created the iframe. Okay, so we have find these two. okay, for the header that loads the JavaScript just now for the file. And also there's one for this creating the iframe. So this is from the retrotic.visionubana.com. So this iframe will load the content from tyu.band.com, which is defined in the HTML body. Okay, so we have found these two. Okay, next, we're going to open the dle.js.js file in choice of text editor, and we're going to examine it. Okay, so you go to dle.js.js. So this one you can close already. Then you observe for this one. Okay, dle.js.js, you right click. Then you open with gedit. Okay, so what is this examine? For this, you can see that, so this file is actually a JavaScript document.write. So it will write the content to the web page that creating an iframe. Just now we detected that there's an iframe, right? And that will tag the user to a URL at tyu.bandme.com, okay, which is the one that I had highlighted here. Okay, so how does the code in the JavaScript attempts to avoid the detection? So actually we can solve this. We can try to splitting the end of the iframe tag into two pieces, which is you can see here with this, okay, /ifr plus ame. Okay, you can splitting the end of this tag into two pieces, yeah? Now, in the text editor, open the text or HTML files that was saved to your home folder with Vivaldi as part of your file name. So I close this. Then I'm going to observe this file, Vivaldi. Okay, right click, open with gedit. So what's next? Examine the file and answer the following questions. What kind of file is this? So this type of file is called HTML files. Okay. What are some interesting things about the iframe? Does it call anything? Okay, so let's have a look. Is there any iframe here? Yes, this is the iframe. On load, Windows set time up is start, is calling the start function. And this start function is visibility is hidden. Okay, so we can find from this coding here. Okay, so what else? So what is this start function do? It will write to the browser window. Okay, it create an HTML form and submit the variable normal URL through the post. So the normal URL variable equals a URI at the tyu.bandme.com. Okay, what do you think the purpose of this get browser function is? So get browser, the function, okay, for this var navigator, then you will have a browser, you got the board is false, browser quality is 0, platform will be a desktop, version full, version short, okay, then you will have all these function. So from here, you will find out that the get browser function is determine the type of the browser that the web page is displayed in. Okay, so we have done all the parts for part 1, part 2, part 3, and part 4. Okay, let's come to the reflection, what you have learned. Okay, so the exploit kits are fairly complex exploit that use a variety of the methods and resources to carry out an attack. Interestingly, EK may be used to deliver a diverse malware payloads. So this is because the EK developer may offer the exploit kit as a service to other threat actors. Therefore, RIGEK has been associated with the number of different malware payloads. Now, the following questions may require you to investigate the data further using the tools that were introduced in this lab. So the EK use a number of the website. You complete the table below. So just now, according to our observation, we already have the IP addresses of 104.28.18.74. And this function is actually referring to the URL of www.homeimprovement.com. Now all these we compile it together, and these IP addresses is the function is for a malicious iframe, redirects to a malicious site. Okay, this is our first finding. And then we also find that the rel www.bing.com, the IP address is unknown. And this function is just like a search engine links to legitimate the web page. Okay. And the third one is about retrotic, the .visionnubrana.com.ve. Okay, this is a suspicious website that we found just now. And the IP addresses is 139.59.160.143. And this is executes the malicious JavaScript. And then we also found out that this website, tyu.banme.com, with the IP addresses of 194.87.234.129, is delivers the malicious Adobe Flash file, which is the one that SWF, okay, and it will exploit the landing page. And the next one, we have the server ransomware checking server. Server ransomware is the one that is attached to your database, and it will lock your database. And after that, if you want to unlock it, you have to make some payment. Okay, so the one that we have detected here is the IP addresses is 90.2.10.0. Okay, and the last one, we also detected there is a server ransomware page that is referring to the IP addresses of 198.105.151.50 and is referring to this attack, this website. Okay, the one that is unknown top domain website. Okay, so it is useful to tell the story of an exploit to understand what happened and how it works. Okay, so start with the user searching the internet with the Bing, and then after that, it will search the web for more information on the rig EK to help. Okay, so the answers will vary. So the purpose of these questions is to start the students thinking about the multiple steps or nature of the EKs and the complexities of cyber attacks in general. So the user is searching the user. So you find out that the user is actually searching for the Bing, www.bing.com. Okay, so for more information about the home improvement, okay, the user click a link to the www.homeimprovement.com. And then this website has been compromised by a threat actor. Now, a JavaScript execute that eventually download a malicious Adobe Flash file. So the Flash file execute and download a malware. So after that, the malware is installed, then it will chat with the CNC server. So that is the whole overall story of what we have learned. Okay, investigating a malware exploit. I hope you learned something from this lab. So thanks for watching. So if you like this video, you can subscribe to my 4M Tips channel.